Hello, and welcome to 5-Minute Math. Today we are looking at the geometric concept of fractional distances in a coordinate plane, and we'll do it in 5 minutes or less. So we've got 2 points and a line representing those 2 points here on this basic coordinate plane. And what we want to do is we want to ask ourselves, what can we do to find a spot that's, let's say, 1/3 of the distance from, let's label these points. This is going to be point A down here. And so I have an x value of -4 and a y value of -12. Okay, and then we have this, let's call that point B, and that's going to be at the coordinates of 4, 6. So what is 1/3 of the distance from A to B? So we have to make sure we know where we're starting and where we're ending here. And I could eyeball this a little bit, but I want to get exact because we can get exact when these are coordinates. And really, we're going to use these two equations we see up here to where the x and the y value of the p, the point we're looking for, is really just a relationship between the initial starting value, right, and then the distance between those two. So let's start with our a. So our a is going to equal, like we said, we've got -4 and -12. So I'm going to use that along with our b here of our 4 and 6. And really, it's the x value and the y value that I'm looking at. So I've got my x sub 1, my y sub 1, my x sub 2, and my y sub 2. All right, so now that we have that, let's start with finding our x values. So the x value of the p, right, is going to equal this first x is our x sub 1. Okay, so what's our starting point? -4 plus this r is my rate. What fractional rate am I using? It needs to be between 0 and 1. I'm using 1/3. So I need to find 1/3, because what we're doing is we're trying to find the change in the x values here. 1/3 times the final x value, 4, minus our initial x value, -4, which ends up being, right, +8. So it's going to be x sub p is going to be -4 plus 8/3. Okay, and so if we want to get a little bit more exact, right, that is going to be almost 3. That's 2 and 2/3. So 2 and 2/3 minus 4, right? So that is still going to be negative. That's going to be -1 and 1/3. Or we can look at that as that 4 is 12/3, and that's going to be -4/3. So -1 1/3, -4/3, however you want to do that. So my x value is going to be right around here, which means I'm thinking my y value is going to be, looks like it's going to be 6, or close to 6. So let's look at y sub p. Same thing, now we're taking our y values. The initial y value is -12, and then we're going to add 1/3 of the difference between y sub 2, which is 6, minus our y sub 1, which is that -12. So that ends up being -12 plus 6 minus -12, right? That's going to end up being +18. Now this one we can uh, easily simplify. It's going to be 1/3 times that 18. So that's going to equal -12. 1/3 of 18 is really 18 divided by 3. So that's 6. And so that does end up being that -6. So 1/3 of the distance between A and B is, and let's go ahead and get our point P here now. I'll write that up here. It's going to be, I've got x value of -1 and 1/3 or -4/3, however you want to calculate it, and a y value of -6. And so there's my -1 1/3, and it does cross that line right there at that -6. So we will label this point P, and we'll put our values there, and that is how we could find fractional distances in a coordinate plane.